Good afternoon. Thank you for attending our webinar, Optimal Approach for Sustainable Rink Refrigeration, co-hosted by Chemours and the NHL with guest speaker Ian Story. This is Kate Becker, marketing specialist with Chemours, manufacturers of Freon and Opteon refrigerants. We're happy to be bringing you valuable information concerning your ice rink refrigeration facilities. The webinar will begin momentarily. All participants have been muted. Questions can be submitted through the GoToWebinar panel on the right of your computer screen at any time during the presentation. Questions will be addressed at the end of the presentation. Now I'm happy to turn it over to Omar Mitchell, Vice President of Sustainable Infrastructure and Growth Initiatives with the NHL.
Thanks, Kate, and hi everybody, good afternoon. It's a pleasure to introduce this webinar in partnership with Chemours. So thank you for participating, especially I'm sure there are lots of hectic, busy schedules all around, so appreciate your time today. For those who don't know me, I work at the League's New York offices here in our Social Impact, Growth, and Legislative Affairs group, and I oversee physical infrastructure aspects related to the growth of our game, basically the places and spaces where hockey is played. And so this can include anything from community rinks to the technologies, products, and services that will ultimately ensure that our infrastructure survives and thrives for future generations. So in case you did not see me on the road show that I attended last year, my colleague Andrew Ferentz and myself, we did a road show across North America, from regional association meetings to national conferences, to explain why the League is interested in this work, right? It's to share best practices and ultimately ensure that our game grows and we increase fandom. And that's why the NHL cares about this work. And one of the things that we've heard as we did our roadshow is, concerns about the R22 phase out that went in effect on January 1 of this year. And that's why our partnership with Chemours as our official refrigerant supplier is so important. And so I know people don't really necessarily want to hear from me, but we did think it would be useful to talk to a rink engineering expert so that he could share his point of view on what rink owners and operators should be considering when they're contemplating new or upgrading refrigeration systems. Ian has been in the industry for quite some time now and has worked on projects with our clubs and around North America. He will debunk a lot of the misinformation that's in the marketplace about options that rink operators have. And I can share personally that I've known Ian for a long time, and I do trust and value his professional opinion and perspective. So I hope that this is useful. Ian, I'm going to pass it off to you now.
Great. Thank you, Kate. Thank you, Omar. Welcome to everybody. I would like to thank everybody for making some time to join us today. I want to start with reviewing our agenda for our short discussion. As part of our introductory slides, I want to recap the agenda for the webinar, as well as the key takeaways for our webinar participants. We're going to talk about myths, rumors, and frankly, fairy tales. We've heard a lot of misguided assumptions in the industry, whether intentional or not. These form a barrier towards upgrades that would enhance sustainability. We're going to talk about the historical approach to ice rinks. We're going to really examine how we got here. We're going to talk about something called system stability. As part of our review of the historical approach, we'll examine the major objectives of previous decision making, highlighting factors that were just not that important at the time and how that does not remain valid today. We are going to briefly talk about Opteon refrigerants, providing the optimal balance of properties. This innovation is the enabler allowing for a fully sustainable ice rink to be achieved. We're going to highlight the specific Opteon products for ice rink applications. We're going to revisit the system stability model of today's decision making and highlight how the optimal approach can be applied to a cohesive package. And we'll have some limited time at the end for Q&A. I invite everyone to submit your questions. While we may not be able to answer them all directly today, We have a variety of information channels that we can use post-webinar so that we can get legitimate information and answers to address any questions or concerns. So key takeaways. It's vital to acknowledge that choices exist. While deceptively intuitive, often this simple idea is met with resistance and industry concern. The rink industry has been the target of more than one occurrence of "this is the best idea ever" due to the energy and overall operating cost intensity. Being a facility that spends more results in a market for, let's call them ideas to save, and let's just call them ideas at this point. Bad experiences naturally increase our reluctance towards changing our approach. The framework today acknowledges that options exist, and there's no best idea ever that is right for all facilities. Not all choices are equal, and the key is finding the way to make the best decision for your facilities. So myths, rumors, and fairy tales. As with all things that are new, there's inevitably confusion and false information, often packaged in a public service announcement, i.e. that it affects the provider, but framed as just so that it was facts, not that it is of importance to the provider of the information. One telling sign of a myth or a fairy tale is the resulting impact on you. Does the information make you somehow afraid or instill fear that you're making the wrong choice? If so, that's the proverbial quacking and feathers of a myth. Some of the funniest, or maybe saddest myths we've heard in industry circulation are that there's only one refrigerant to make good ice. So the technical term for this myth is nonsense. Good ice is a sum of its parts, water chemistry, application, environmental conditions, and floor temperature. Floor temperature, where refrigeration meets ice, is about system performance and does not rely on what type of refrigerant is used. The ice doesn't know what refrigerant is being used. It's driven by temperatures achieved and maintained only. I promise that a floor of 20 degrees Fahrenheit will freeze when water is applied to it, regardless of what type of refrigerant got it to achieve that 20 degrees. New refrigerants were invented to get around regulations. This is the old cook the books rumor. It's clear, if you use the semi-mystical power of Google, that great industry award-winning efforts have gone into refrigerant developments. Far less efforts would have been needed to get around regulations. Further discussion of this rumor is beyond this systems webinar, but if you have further doubts, I'd encourage you to simply look it up yourself. Using new refrigerants will make your energy costs increase. This blanket statement is difficult to delineate because it's simply meant to instill fear. It's possible this could happen. However, applied rink engineering will either mitigate or prevent this from happening. Certainly, it's been our field results that cost reductions are very realistic and are being achieved. Sustainability is only about GWP, global warming potential. Ice rink sustainability is not only about GWP nor environmental stewardship. It's about both environmental and financial factors. Focusing on GWP only promotes a distraction about and away from the real and present operating cost issues, including both energy and maintenance. We're going to talk about that a bit further in the webinar. So when it comes to choices, as I touched on earlier, choices exist. Fear about making the wrong choice is often very powerful and impedes progress towards achieving sustainable rink status. So let's look at the need for progress by examining the history of ice rink refrigeration. Historical approach for stability. Three major considerations were at the heart of previous choices for ice rink refrigeration: safety and regulatory, performance and sustainability, and reliability, maintenance, and operability. On safety and regulatory, R22 was popular due to its non-flammable and non-toxic properties. However, the use of toxic refrigerants wasn't viewed as concerning with limited external consideration or concern. Performance and sustainability. Effectiveness, not necessarily efficiency, was the deciding factor. That is, the measurement system was, is the water frozen for a reasonable spend? Keeping in mind that energy costs were also low and less of a financial burden. And when it came to reliability, maintenance, and operability, predominantly these were based on other practitioners' experience. The concept of low maintenance equipment wasn't a common topic of discussion. Okay, so the historical approach to systems. So this is almost as old as I am. This is a published standard Rink refrigeration system. It was a public sector document from 1979 that documented what was considered common knowledge, that this was the standard Rink refrigeration system over 40 years ago. And this legacy industry standard was a flooded refrigeration plant with piston compressors and an outdoor condenser, no energy recovery, and R22 was commonly used because of its non-toxic and non-flammable nature. When considering options, there are reasons why R22 was used in existing systems. Revisiting the core pillars reveals new gaps and challenges. System instability. As denoted in red, we have a number of items that have changed or changed in emphasis or consideration, resulting in today's rink operations being subject to a state of unsustainable. Safety and regulatory. So evacuation and population densities have changed. Consideration to external spaces and the impact on public places of assembly, particularly when using a toxic-based refrigerant, are leading to evacuation plans driven by fire services, and these are not uncommon and place additional burdens on operations. On the regulatory side, upgrades to plant rooms are, as a result of regulatory changes, depending on the refrigerant selected, are particularly burdensome if utilizing a flammable or a toxic refrigerant. This adds additional costs to the particular business. Performance and sustainability. HCFC phase out. The impact in particular for R22 based sites puts increased financial risks for maintenance costs and continued continuity of service, resulting in a financial impact. And as for reliability, maintenance, and operability, aging infrastructure and rising maintenance burdens related to the maintenance cost burden and continued risk of service and revenue. Finally, the intuitive nature of the Rink operation system. As new operators are entering the industry, the need for intuitive operator interface is required. It is no longer the rule that all employees of the Rink have been working there for a very long time, as the culture once had been. So breaking them down a bit further, the optimal approach for considering safety. Ice rinks are public places of assembly. Ice rinks are often located in places of high population density. There is increased public awareness and demands for safer spaces and communities. Regulations are adapting or responding to the need for safety as paramount. Do you have or should you have evacuation planning in place? Some of the best practices to address these considerations include use of non-toxic and low or no flammability refrigerants. This is among the reason R22 was historically a popular choice for the ice rink application, with user and employee safe space design factoring the rink surrounding area impact.
Phones, just dial 311 or go online to www.rink
classification.
/311.
A quick review of refrigerant classifications, denoting the increasing toxicity and increasing flammability characteristics. The most commonly used ice rink refrigerants of the past were R22, non-toxic, non-flammable, and ammonia, which was toxic and mildly flammable. The Opteon refrigerants XP10 and XP40 are both category A1, non-toxic and non-flammable, as was R22.
Most livable city in America. Become a volunteer. For more information on volunteer opportunities, visit www.volunteerevanston.org. Volunteer today.
So, some common ice rink refrigerant comparison: ozone depletion and global warming potential. There is a lot of discussion of global warming potential in the industry. It is important to note that this is a potential if a release were to occur. If systems are installed with high quality components so as not to leak, that potential remains just that, only a potential. GWP GWP is a system with CO2 as the basis of measurement. Reviewing the commonly applied refrigerants to ice rinks, it's clear how Opteon refrigerants have provided a dramatic improvement in what is only a potential. System stability, reliability, maintenance, and operability. So getting back to the optimal approach and considering reliability, maintenance, and operability aspects, the total cost of ownership and considering reliability, maintenance, and operability needs to be fully taken into account. Focusing not strictly on efficiency of a pound of refrigerant, but the total cost, including efficiency, reliability, and maintenance costs. Reducing maintenance outages and emergency repairs reduces costs, period. Smooth transition for staffing changes. As new operators enter the industry, the tools to allow for increased operational awareness and abilities is vital for the sustainable ice rink. Recalling this includes both environmental and financial aspects. So from a best practices to address these, considerations include redundancy, failure point reduction to avoid that single point of failure scenario, curtailed maintenance costs and requirements. The movements toward low or no maintenance equipment is clearly beneficial and realistic, and in fact is being seen in the industry today. Intuitive and remote operator interfaces, as previously noted. System stability, performance, and sustainability. And the final stability column to consider, effective and efficient. This is the performance with optimized equipment operation, not simply zero complaint status. Increased financial flexibility, reducing operating and maintenance spending, results in capital being available for ice rink business enhancements and overall sustainability. Reduced environmental footprint. User groups and society as a whole are expecting, if not demanding, better. Reducing operating energy will reduce associated emissions and the impact those have on the environment. Best practices to address these include balanced service delivery, incorporating noted improvements or upgrades which allow for all facets of sustainability to be addressed. A fiscally responsible approach to ice rink facility is required to achieve the overall sustainability, which can be realized achieving an environmentally advanced ice rink refrigeration system. The NHL partners with Chemours. As a vital piece of providing the underlying solution towards ice rink sustainability, the National Hockey League partnered with Chemours in May 2018. And you can read more about their partnership at www.nhl.com/Opteon. Opteon refrigerants enable the optimal approach. Opteon refrigerants were developed to help customers meet increasing market demands for high performance, more environmentally sustainable refrigerants and blends, fueled by increasingly stringent global warming regulations around the world, as well as changing consumer preferences. As previously noted, the XP10 and XP40 products are particularly applicable for ice rink applications. And you can find out more about these refrigerants at www.nhl.com/Opteon. So the optimal approach, summarized. We need to include the opportunity to embed key advantages with any upgrade being undertaken. The value delivered is more than just efficiency. It's about the sustainability of the ice rink operation, both environmentally and financially. And so, under our core pillars, we can see that applying these best practices, we result in a non-toxic environment, employee safe workspace, safe place of public assembly, low GWP, lower energy footprint, better service life, financial viability, and long warranty options on equipment with remote operator access and reduction in our emergency or ongoing repairs. There are a spectrum of solutions. System options exist, providing a range of capital cost solutions. Financing solutions can be custom tailored to the ice rink industry to make it easy to get conversions done. Full equipment packaging financing solutions are available. And remember that any solution should be customized to the individual facility's needs. Achieving sustainability by applying the optimal approach. Application of the optimal approach will move an unsustainable ice rink towards a sustainable ice rink, recalling that sustainability is about both environmental and financial implications. So why wait? Inaction leads to continued utility spending, continued maintenance spending, and continued risk for operation and or revenue losses. Whereas conversely, the applied optimal action approach will lead to enhanced safety, reduced operating, and address maintenance costs and provide risk reductions. So this concludes our webinar, and we'll now open it up to any questions that may have come in.
Thank you, Ian. I appreciate the information and the insight that you've shared today. So to those on the line, again, you can submit your questions as part of the GoToWebinar panel on the right-hand side of your screen. We've already gotten a lot of questions, so appreciate a lot of the interaction and feedback. We'll try to answer however many we can in the next couple of minutes, and if not, as Ian mentioned, we'll follow up with you after the webinar. So we also happen to have on the line with us Dr. Chuck Allgood as part of our technology team here at Chemours. So Chuck, I have a question for you that came through on the line. So the question is basically, I've known that natural refrigerants like ammonia and CO2 are the most sustainable refrigerants out there, and synthetics are not. But the info presented on the webinar shows that Opteon refrigerants are also sustainable. So what really is the truth?
Yeah, what is the truth? Good afternoon, everyone. This is Chuck Allgood. As Kate mentioned, I'm with Chemours Refrigerants Technology Team. So the truth is there is really no natural refrigerant. So the natural versus synthetic, I think, is an artificial battle that's been set up. There are refrigerants, and they have different properties and different applications where they can be used and perform differently. But anything like propane, isobutane, ammonia, carbon dioxide, fluorinated gases, they're all synthetic. They're all produced in a chemical manufacturing plant through chemical processing, purification, packaging, They have to be transported. They consume energy. They consume raw materials. They produce waste. So I don't put a lot of value in designating natural versus synthetic. I think we need to take a little deeper dive into the science and to the engineering to look at sustainability. And sustainability, I think, as Ian mentioned, is environmental sustainability. You have ozone depletion concerns, you have global warming potential concerns, and then there's financial stability. So what we're trying to do is come up with solutions that allow people to make the best balance of those type of properties and to choose the best option and a technology that's going to be sustainable for the long term. And when I say the long term, I really mean for the life of their equipment or their investment. Who knows what's going to happen 50 years from now. We may be all on some science fiction magnetic-based cooling. But for the life of your equipment, you really need to look at the properties from a sound engineering, science-based perspective.
Thanks, Chuck. I appreciate the answer. And another question that comes through the line, Omar, I believe this is directed towards you. The NHL is concerned about community rink infrastructure, but what are they actually doing to help this shift to sustainable refrigerants?
Good question. Good. So, I think it's a couple of things. As I mentioned at the beginning of the call, we at the League are really trying to understand the industry needs and determine how the League can help solve some of these issues. And as I said, one of the things that we've heard is really around the R22 phase out and to your point about the shift to sustainable refrigerants. When you hear folks like Ian and Dr. Chuck talk, so choosing a refrigerant, it's just one part of a much broader series of questions, right? And so what the League is trying to do is share the best practices and the things that have worked in the industry that we've seen, is to understand what solutions are out there that make sense for the rink operator. Because a lot of it, as Ian said, is a lot of misinformation in the marketplace. And the idea is that we want to promote that there are alternatives for any of the types of, especially energy efficient retrofits and upgrades that are out there. And we want to debunk some of those myths and ensure that people know what the solutions are. And along the lines of sharing what those best practices are, to Dr. Chuck's point, we have to prove that it's not just, as much as I'm all about environmental sustainability, sustainability is also measured in financial sustainability, cost of ownership, and making sure that you have a viable business alternative when making these decisions. So things like financing, which we've heard in the industry is a major pain point for rinks. How can I pay for these upgrades? We have solutions that we have engaged with NHL corporate partners to engage on financing solutions to help rinks, both municipally owned as well as privately owned. We engage with folks like Ian, application specialists who think outside the box, right? When considering upgrades. So it's not just a mechanical engineer telling you what you should be implementing, but we're thinking about the whole system, how your ice rink, your ice refrigeration system connects with your HVAC system, connects with your dehumidification system and building automation. We think about experts who can tell you and program the entire system, not just one component part. We think about folks like OEMs who would offer these types of solutions so that they are providing the not just the actual metal, the steel, but also the warranty and service and support around this. That's what we bring to the table. Think of it like a hat trick. We think of it as something where we're offering all of these along with the corporate partners like Chemours to educate the marketplace in a meaningful way. Sorry, Kate, that was a long answer, but back to you.
Thank you. I appreciate it. I know we're coming up on 2:30, so I appreciate everyone staying on the line. I'm going to try to squeeze in one more question before we say goodbye to everyone. So, Chuck, back to you. Quick question. I realize it's not a simple yes or no question. Will Opteon refrigerants work with existing R22 equipment?
They will. They can and they will. If you have an existing R22 system, let me just say this: you have basically three options. One, you can continue to run it on R22. Don't be fooled by any myths. There's nothing illegal about running that. You just have the risk if you have a major leak, cost and availability of replacement R22. Another option is to replace the equipment entirely, brand new system. Obviously, that's a lot of capital and some downtime trying to do that. To the question asked, running Opteon on an existing 22 system, you can do that. We have done that successfully in a number of locations. You typically need to do some modifications, and you probably want to have one of our engineers or a good engineer that you hire look it over, get in contact with us to make sure that the controls and everything can be tweaked and changed, and so you know how to make it run as reliably and as efficiently as possible. So, yeah, it's not a simple drop-in. There is no such thing as a drop-in, but it is possible to say do a conversion or a gas retrofit for an existing 22 system.
Thank you, Chuck. Appreciate it.
And yeah, please feel free to reach out to us if you want to discuss it.
Absolutely appreciate that. So, unfortunately, we're at our time, and in respect of everyone, we'll end the webinar. We appreciate you attending and listening in. Please visit optforbetter.com/NHL. There's additional information and how Opteon refrigerants can be used for the optimal approach, as well as a recording of the webinar will be posted to that page in the future. So again, thank you for participation, and we hope you have a good day.
Thanks, everybody. Bye.